Hello, my name is Will Rand, and this is my Project 1.2 Analog Oscillator Supplemental video. This is my prototype, but I'll be using it to demonstrate the components and how the circuit works. So, as we know, transistors act as switches and sometimes amplifiers, but while acting as switches, when these are on, they provide a more direct path for current to flow through this LED, and when these capacitors discharge, it flip-flops and switches to the other side. Now, in terms of components, we have two 1K resistors, two 10K ohm resistors, two 100 microfarad capacitors, two 3904 transistors, two light-emitting diodes, and wiring to complete the circuit. In terms of the final circuit, you can see here that we have the addition of a side switch and 3 terminal blocks, which can be used to attach LEDs or provide power over here. So, speaking of these components that make up the majority of the circuit's functionality, the capacitors are able to store and release electrical energy by accumulating charge on opposing plates wound up within this little cylinder, which is separated by an insulator. So they can basically temporarily store and then supply energy back into electrical circuits. And as for these transistors here, they can control electrical currents in circuits, and they amplify or switch signals by sort of receiving charge on one pin and then emitting it through another. Now, we touched on in class how there's a time constant throughout a circuit with capacitance. So in order to calculate that, we'll use tau. So tau equals RC. Now let's say that our R equals 1K, our capacitance equals 100 microfarads, then our time constant would equal about 1/10 of a second. Thank you for watching.